Alrighty, so in this question, what essentially is happening is they're asking us the power dissipation to this current dependent voltage source. Another voltage source, the amount of voltage it's delivering depends on the amount of current which is passing through this 50 ohm resistance, right? And the way to estimate the power dissipation itself would be to multiply the voltage, which is dependent on the current source, multiplied by the current itself, which is passing through this branch, right? Now, to go about this, what we are essentially trying to first do is find the amount of branch currents. Now, these are the three branches present in the circuit. That's first branch, the second branch, and that's our third branch. For these, we can draw the estimated current direction. We can do all of them to be clockwise loops. Yeah, I will make three clockwise loops, and I will label them as such: I1, I2, and I3. Yeah. Now, one thing to notice is the Ix current is essentially equals to the I1 current which is coming down minus the I2 current which is going up, right? So Ix current is essentially the I1 current minus the I2 current. That should probably be our first equation. Now with this, we can try solving one branch at a time. We can start with the third branch. Now the way to estimate the polarity is if they have not given the polarity for the resistors, the direction of the current. Now you see that the direction of the current in this loop or branch is clockwise, right? So it starts with this node, it enters this node, it comes here, it goes here, and it goes all the way back up, right? So when it's coming from here and it's going clockwise, the direction in which the current enters the resistor is positive by default in all the resistance, right? So you can write this for this current, yeah? It changes for every different current. And you notice that after all these resistance, it's going back to the negative terminal, right? So if a current enters a positive terminal, the polarity for that resistance will be positive, and the current itself is I3, so I will write I3 here. Yeah. Now it enters the 15 ohm, the positive direction of the resistor, so that's 15 again, and then I'm multiplying it with I3. That is the current. The loop current should be considered first, and since the I2 current is going in the opposite direction to the I3 current, you subtract I2 here. Yeah. And then we go with the last 10 ohm resistor. Since the current is entering the positive side, it's again plus 10. And since we're considering the I3 loop, I3 should be written first. And since I1 is going in the opposite direction compared to I3, we subtract I1. Yeah. And you notice that it enters the negative terminal of 660 volt in the end, so minus 660. That gives us the first equation. Yeah, equation number one. Now we can try simplifying this. This is 5, this is 15, 20, and that is 30. That's 30 I3, right? And what is this I2 going to be? It's minus 15 I2. Yeah. And then finally it is plus 10 I1. Yeah. We bring 660 the other side, becomes positive. So that's us simplified. You can simplify it further, but since I'm going to put them in a calculator, I think I will leave it be as it is. Now the second equation, the second branch is this one, right? We again, now we do clockwise again, starts here, it enters here, it comes here, goes here, and it enters back all the way up, right? So it takes a clockwise routine. So since it's entering this part first, like this is going to be positive by default, this is going to be positive, negative, and this for this current is going to be positive and negative. So since it's entering positive, you can since the current enters the positive side, you can consider 25, and the current itself is I2, right? And then it's entering this section, you see it's positive side again, so it's 50. The current is I2, and you see that I1 is in the opposite direction to I2, so you subtract I1 from this, and then but you always make sure that you start with the current you're considering. So it's not I1 minus I2, it's I2 minus I1, because you're considering the current I2, right? If you were considering the current I1, it would have been I1 minus I2. So that's the difference you have to remember. Now in this case, it is I2 minus I1. Now in the last resistor, it's entering the positive side of it again. So it is positive 15. And then you do I2, we're considering I2. Since I3 is in the opposite direction, we subtract. If I3 was in the same direction, we would have added. So that's the only difference, right? Now, another thing to consider here is, if this is confusing you, just make sure that you can keep the polarity to be anything, but the elements which are losing power and the element which is supplying the power should have the opposite polarity. So, for instance, this is a resistor, this is a resistor, this is a resistor, all have the same polarity, and the voltage has the opposite polarity. So I could have technically written minus 5 I3 minus 15 I3 minus I2 minus 10 I3 minus I1 and plus 660, and that would have also been the same. So it's up to you, but you just have to make sure that the voltage source or the current, so whatever is giving the supply, and the elements like resistors, they have the opposite sign. The easy way to go about this is to like consider the positive and the negative signs and to go in that way, but you can have it written any other way according to your convenience. Now simplifying this will give us 25 I2, that is 50 I2, that's already 75, 80, and 90 I2. So that's 90 I2. Now for I1, you have minus 50 I1. So I'll write minus 50 I1. And finally, I have, what do I have? This I2 is gone. So I just have minus 15 I3, right? And by the way, this is negative 10. I wrote that by mistake, since this is 10 and there's a negative sign here. So it's minus 10 I1. Yeah, just be careful about the signs. But yeah, I think that's about it, and this is equals to 0. That becomes a second equation. Now our third equation is just this section. I will again start with this end. I'm going to go clockwise, come here and come here again. Since current is entering the resistor, this part should be positive, this should be negative, this should be positive, negative, and you notice that it enters the negative part of the voltage source. So for whatever positive side it's entering, that'll be positive itself. This is the third equation. So it's going to be positive 10. And since we're considering I1 current, you write I1 first. And since I3 is in the opposite direction, I write minus I3. And then it's plus 50 once again, because we're entering the positive side of the resistor, and it's going to be I1, and since I2 has the opposite direction, it's minus I2. And you notice that it's entering, it's going this way, it's coming here, it's coming here, and it's entering the negative part of the dependent source, so it's minus 20 Ix. Now Ix is equals to I1 minus I2 from this equation, right? So you basically write I1 minus I2 is equals to 0. Now we try simplifying this. It's 10I1, 60I1 minus 20, so it is 40I1. Yeah. Now I3 is 10I3, so minus 10I3. Finally, you have minus 50I2 and no, plus, yeah, minus 50I2 and minus and plus 20. So it's going to be minus 30 I2. Yeah, so these would be our three equations. You can put them in the calculator. It will be in the order, so was minus 10 I1, minus 15 I2, plus 30 I3 equals 660. First equation. The second equation is minus 50 I1 minus plus 90 I2, finally minus 15 I3 equals 0, and the last equation is essentially 40I1 minus 30I2 and minus 10I3, which is once again equals to 0. Now you can put this in your calculator, right? And when you put that in your calculator, you'll have to give me 1 second. Okay, you'll have to type this out on your calculator, and I think you should get your answer. Just 1 second. Okay, that makes sense. Fine, I'll just type this out and we'll check the answer. You'll have to go to the equation mode, which is the fifth mode, and then enter the second one, which has three equations. So it is minus 10, minus 15, and 30, 660. Yeah, and then it is 90 and minus 50 and minus 15. Lastly, it is 40 and oh sorry, it is minus 50 there, and then it is 90, then it is minus 15, 0. Okay, now it is right. And then the last equation is 40 and minus 30 and minus 10. Okay, and that's 0. So you'll have x, that is the I1 value, to be equal to 27 amperes. The I2 value will be equal to 22 amperes, and the I3 value should be equals to 42 amperes. Yeah. So now you have all the three currents. What's the voltage going to be, by the way? Now voltage is nothing but 20 I1 minus I2, right? I1 is 27 minus I2 is 22, so it is 5. Yeah. This is going to be 100 V. So technically the voltage here is 100 volt. Yeah. So the power is basically 100 volts times I2 current. Since I2 current is, sorry, this is I1 current. Since I1 current is coming here, it's I1. So that is going to be the amount of power dissipated through or power produced, actually, I would say. I think it's the power produced, power delivered, sorry. So the power delivered would simply be 2700 watts. Yeah. So that's how you work with polarities and calculate the power dissipation. I hope that helps.